In this video, we're going to continue looking at graph transformations, specifically stretching and compressing a function. We'll start with vertical. I'm going to use absolute value of x as our parent graph. I've got the dashed blue line so we can use that for reference. And I'll use a reference point of 3, 3 so we can see how the stretching and the compressions change the output of the function. Multiplying by 3 on the outside stretches the function up. It's as if I could grab the ends of the absolute value function and stretch it up towards the positive y-axis. When I plug the value 3 in here on the green graph, the output value is 9. It's 3 times higher than it was in the original graph. Similarly, if I multiply by a fraction, the function is not growing as quickly, and when I plug 3 into the function, I'm only at 1 for the output. So anything on the outside that's a whole number is going to stretch vertically, and a fraction is going to shrink vertically. Let's look at a different example. Let's look at the square root of x. Here's our parent graph. We'll use the point 9, 3 for reference. Multiplying by 3 on the outside is going to stretch the graph up, and that reference point, plugging 9 in, is going to have 9 as its output rather than 3. If I multiply by a 1/3 on the outside, the graph is not growing as rapidly, and plugging in 9 gives us only 1 as the output. Just like we saw in the vertical shifts, any number that is going to make a change will be on the outside of the function, and a whole number will stretch and a fraction will compress. Let's look next at the horizontal stretches and compressions. Horizontal changes happen when we put something inside to the function, so putting a 4 inside the absolute values or a 1/4 inside the absolute values. This is going to have the opposite impact that we would expect. So when we multiply by 4, it's actually shrinking the graph in from left to right, sort of like an accordion. The way that we can see this is by using the reference point 4, 4 on the original graph. The point 1 for input is going to produce the same output. So I don't have to go as far over to get the same output because that graph has been compressed in. Again, the 4 being multiplied on the inside is pushing the graph in, whereas a 1/4 is stretching the graph out to left and right. In this case, to get to the output of 4, I have to go all the way out to 16. So when we multiply by numbers inside a function, it has the opposite impact we would expect. A whole number compresses the graph and a fraction stretches the graph. Let's look at the square root of x for another example. Here's our parent graph, and we'll use the point 25, 5 as our reference. If I multiply by a number on the inside, 5 in this case, the graph is growing. Even though it looks taller, it's actually growing at a lower rate because when I plug in the number 5, I'm going to get 5. So this point here was moved all the way back over to the left. So that's where it has been compressed. When I have a 1/5 on the inside of the square root, now to get to that output of 5, I've got to go all the way out to 125. Let me zoom out here. All the way out here to get that same level of growth. So the 1/5 is actually stretching the graph out to the right, where the 5 is compressing the graph more towards the y-axis.